So we're going to begin our conversation about conic sections. Basically what conic sections are is they're cross sections of a couple of cones. And what I've done is I've shown you all those cross sections right in front of you. The first one we're going to look at is a circle, all right? And that cross section is basically a horizontal cross section across that cone. Then I believe we'll take a look at an ellipse, whereas if you slice a cone at an angle, a singular cone, you get the ellipse. If you take and draw some form of a slanted or vertical cross section of the two cones, you get this hyperbola. And then if you just take a parallel cross section to one of the cones, you'll get the parabola. All right, and like I said, today we're going to start our discussion of conic sections with circles. Now we remember back from geometry, maybe even algebra 1 and definitely algebra 2, that if you have a circle centered at the origin, the equation for that circle is x squared plus y squared equals r squared. We can see that from the following. If this is 0, 0, and I put a point out here of x and y, I know that creates a radius of the circle. And then the relationship in that right triangle is just x squared plus y squared equals r squared. Anytime we move that circle somewhere else, we get a translation of some hk very similar to our apparent values. And our standard equation is just x minus h squared plus y minus k squared is equal to r squared. Now there's such a thing as a general equation for a circle, and that's given by the following: x squared plus y squared plus dx plus dy plus f. The only problem with the general equation is it doesn't really give us much, whereas the standard equations give us both the center and the radius of the circle. Our first question is going to be to find the radius and the center of the circle given the following equation. Well, like I said, the standard formula gives us all that information within it. All we need to do is find our hk. Here's our h, here's our k, and remember that this is in y minus k form, so our center is going to be at 5 and negative 9. And then for our radius, we need to know that this is a squared value, so the square root of 10 is equal to our radius. Next, they give us a center and a radius, and they want us to write the equation in the standard form, so that's just going the opposite direction. So I know that this is my h value and my k value, and r is given to us. So I know I have x minus h. So x minus a minus 4 is plus 4, quantity squared, plus y minus k, and that's a 6, is equal to the r value squared. So that gives me x plus 4 squared, y minus 6 squared. 9 times 5 is 45. And that's my equation. Now the next thing we want to do is we want to put this equation in standard form. And the best way to do that is to complete the square. So in order to complete the square, you'll remember that we have to have coefficients of 1 in front of our squared terms to do that. And we do. So what I'm going to do is I'm going to group together my x terms and then my y terms. And I'm going to isolate the constant on the other side of the equation. Now, if you remember from Algebra 2, completing the square involves taking the b value of a quadratic, dividing it by 2, and then squaring it. So the b value in terms of the x is negative 10. So if I take half of negative 10 and square that, I get 25. And if I take half of 14 and square that, I get 49. So now what I've got is I've got an addition of 25 to this guy here, and an addition of 49 to this guy here. But if I've added the 29 and the 45 to the left side, I must add the 25 and the 49 to the right side. So now you'll notice I've created two perfect squares, which can both be factored. This goes to x minus 5 quantity squared. This goes to y plus 7 quantity squared. And this ends up being 75. So if I really wanted to, my center would be 5 and negative 7. And my radius would equal the square root of 75, or 5 root 3. Again, we're going to write the equation of the circle in standard form. We notice in this case, though, that the coefficients in front of the x squared and the y squared aren't 1. So the easiest way to deal with that is to divide everything by 3. So what I end up with is x squared plus y squared minus 4x minus 6y plus 1 equals 0. And then it just turns into the same problem as last time, where we group the x's and the y's. Isolate that constant term on the other side, take half the middle terms, square them on both. Whoops. It's going to equal 9. Add those new values to the problem. Remember to balance both sides. And then end up factoring our perfect squares. So I end up with x minus 2 squared plus y minus 3 squared equaling 12. And there I have my standard form. So next we want to write the standard equation of a circle with a radius of 7, whose center's in the second quadrant, and the circle is tangent to the y-axis at 11. So we've got a lot going on here. I believe in drawing pictures. So I know, first of all, my center's in the second quadrant. So quadrant 2 is over here. And my circle's tangent to the y-axis at 11. So let's call this 11. And then tangent means it touches in exactly 1 point. And it also says I have a radius of 7. So the length of that radius here is going to be 7. So I've got some circle that looks like this. Obviously not totally to scale. All right, which means I need to know my center since I already have the radius. So I know that if it's tangent at 11 by geometry, I know that the point of tangency and the segment that it's tangent to is always perpendicular to the radius. So therefore I know the y value of my center, which is going to be 11. I also know, since it's going across at a straight line and my radius is 7, then that puts me at negative 7 over. So negative 7 and 11 is my center. And now I can write the equation of x plus 7 quantity squared plus y minus 11 quantity squared is equal to 49. And I'm done. So drawing the picture really assists us in writing that equation. Next thing we're going to do is we're going to write the standard form of the equation given a diameter with certain endpoints. So again, here's a circle. I've got the diameter 6, -4 here-ish, -4, 12, say here-ish, and I need to write the equation of this circle. Well, I know if this is the diameter, halfway between that gets me my center. So in other words, I need to find a midpoint. So the midpoint is just going to be the average of the x's and the average of the y's. So I've got -4 plus 6 over 2 and 12 plus -4 over 2, which gets me 1 and 4. Then what I'm going to have to do is find my radius. So now that's just like finding the distance from that center out. So I'll do that by taking 1 minus 6, squaring that. That's the difference of the x's. The difference of the y's is 4 minus -4 squared, and I'll square root the whole thing. So I have -5 squared, 8 squared, square rooted. So this is going to be 25 and 64, or square root of 89. So now that I have my center and that distance, which is also equal to my radius, I can write the standard equation of x minus 1 quantity squared plus y minus 4 quantity squared is equal to r squared, or 89. Next problem is a little more difficult. I've got 3 points, and I need to write the general form of the equation of a circle passing through those points. So let's write that general form: x squared plus y squared plus dx plus ey plus f equals 0. I have no idea what d, e, and f are, and I need to know those in order to write this equation. The only thing I have here are these 3 points. Well, points come in the form of x and y's. So I've got 1xy, 2xy, and a third xy. Well, if I have 3 x and y values, that means I can plug x and y into each of these equations and get, or plug it into this general equation and get an equation with 3 unknowns. Thus, I'll have 3 equations with 3 unknowns, and I can solve a system. So let's at least start that and set the system up. So if I have the point 0 and -9, like so, and I plug that into my equation, I have 0 plus 81 minus 9d, oops, sorry, 0d, because that's my x value, minus 9e plus f equals 0. If I use the point 7 and -2, then I have 49, because that's x squared, 4 y squared, plus 7d minus 2e plus f equals 0. Next, I take the point -5, -10, plop that in, get 25 plus 100 minus 5d minus 10e plus f equals 0. And if I rewrite all these, then I have -9e plus f is equal to -81. I have 7d minus 2e plus f is equal to negative 53, and I have negative 5d minus 10e plus f equaling negative 125. So here's my three equations and three unknowns, and that's my system. Now, we can go through longhand and solve that system, or we can use a process that hopefully we all learned last year of using matrices to solve this. Now, I know we haven't used matrices this year, but let's just review. Any three variable system can be drawn up in a matrix form, or an augmented matrix form we call it. So I take the coefficients of this, which are 0, negative 9, and 1, 7, negative 2, and 1, negative 5, negative 10, and 1. That represents the coefficient matrix. The unknown matrix would be D, E, and F. And then the solution matrix would be negative 81, negative 53, and negative 125. And if I were to multiply, I'm going to call this my A matrix, my unknown matrix, and my B matrix. If I multiply this A matrix by this X matrix, I get my top equation, because rows by columns, and that would be set equal to the negative 81. Now, if you remember from last year, that if I want to find my unknown matrix, I need to take the inverse of my A matrix and multiply it by my B matrix. But in order to do this, we're going to need our calculator. So let's get those out. So what we're going to want to do is we're going to want to plug in these matrices into the matrix mode of our calculator. So let's do that. We hit second, followed by our matrix button. And we're going to want to edit, so I have to move over to edit our matrix A. And right now it's a 1 by 1, and we want to make this a 3 by 3. And there we have it. So now we're going to fill in the A matrix in this 3 by 3 spot. So I have a 0, negative 9, and a 1 in my first row, a 7, a negative 2, and a 1 in my second row, and then a negative 5, a negative 10, and a 1 in my third row. And now that I have all that plugged in, I want to quit that. And then I want to go back into the matrix, so I hit second matrix again. And this time I'm going to edit, so I move that over to edit, my B matrix, which is a 3 by 1. There we have it. And I want to plug in the negative 81. Whoops. Negative 81. A negative 53. And a negative 125. And once all those three are in, I'm going to quit that as well. And now what I want to do is I want to take and do my multiplication of the inverse of A times B. So let's go ahead and do that. We go second matrix, and I hit number 1, and that pops up my A matrix on the screen. And I want to take its inverse. So underneath the math button is the inverse button. And then I'm just going to multiply that by my second matrix. So I'll go matrix, move down to 2, and it throws up the b right there. Now those two will be multiplied together. Hitting enter, I end up with 10, -6, and -135 as my D, E, and F values. So now that I know that, I can go back and write my general equation. So I have x squared plus y squared plus dx dy and f equals 0. And that's my general equation. That'll do it for the day. And do a little calculator practice on that third problem, and we'll see you tomorrow.